In the particle physics, the particles are described by the field, which is the defines random space-time. And in the standard model, there are three different types of the field: scalars, fields, spinor fields, and vector fields. They can be classified as spin, and especially the such as spin classifications, actually the representation of the Poincare group, but there's some deep algebra things will be skips here. I will focus on the what is the scalar spinors and vector fields to obtain the some of the technical and the practical ways to learn the particle physics. In the relativistic quantum mechanics, there are two important formula. There are some relation between the energy, momentum, and the mass from the Bohr momentum. And in the quantum mechanics, the energy and the momentum apparatus can be represented by the ddt and the ddx. And by combining up the both things, we can obtain the Klein-Gordon equation as a relativistic quantum mechanics. It represents the propagation of the Bliss-Scalar field. From the relativistic energy momentum relation, we can insert the operative form of the energy momentum operator ddt and the ddx to the p, and it yield that such a partial scale plus m scale with the pi equal to GLs, such an equational motion, so-called the Klein-Gordon equation. And the corresponding Lagrangian can be written by the kinetic term and the massive term. The solution of such a Klein-Gordon equation is a plane wave form. And in general, it can have also positives and negatives energy, since the E scale is equal to the physical RAM scale relation. So if we calculate some probability current density as we are frequently calculated in the quantum mechanics, it can be obtained by the complex conjugates of the field times the Klein-Gordon equation minus field times the complex conjugate of the equation of motion. These techniques also used in the probability current in the Schrödinger equation. And by that, we can obtain the probability current density as this form. This is very similar in the quantum mechanics. And by inserting the solution, the probability density is proportional to the energy. And energy can be negatives, and negatives probability current density is physical. So such a second derivatives, the behaviors of the so appears in the equation of motion, and it yields the negative energy and negative current density. And this can be avoided by using the just first derivative. But in the deep algebra, the such a Dirac equation, the spinors that comes from the representations of the Poincare group, there are some of the double curves compared with the just Poincare groups around us to see, but I will skip about the algebra thing. Maybe that it can be discussed in the QAPT course. So in the Dirac equations, it describes the propagation of the free spinor field, and the Lorentz invariant quantities are given by the such a adjoint spinor psi bar psi, where the adjoint spinor is defined as the psi bars are equal to the psi dagger gamma 0, where the gamma is the gamma matrix here, and also the such a psi bar gamma mu psi is a Lorentz covariant vector. So the such a full quantity with a partial mu contraction with the gamma matrix, it becomes a Lorentz invariant scalar. So we can construct the kinetic term and the massive term by using this two Lorentz invariant quantity, and by from this equation Lagrangian, we can explain the Dirac equations. Actually, such a Dirac equation can be derived by the other way by defining the alpha and the betas, and we can bind the gamma matrix to satisfy the energy momentums relations in the relative theory, and there are only the first derivatives. But such a gamma matrix has a more deep and interesting meanings in the algebraic point of view. Such a gamma matrix, the 4x4 gamma matrix, and maybe in the next videos I will talk about what the gamma matrix is in more detail. And such a mu index is constructed, so the gamma G partial G such a index as also might is here. So the such a gamma 0 is a radical by 4 matrix. So the be careful about such dimensions of this gamma matrix. So the such a spinor is the 4 by 1, and the joint spinor is the 1 by 4. So the gamma matrix is 4 by 4 is the acts on such a spinor. So in a similar way, we can obtain the probability density by the complex conjugates of the spinors and the equation minus 3 in the complex conjugate. And from that, the probability density is again by the side of psi, which is becomes a positive now. And finally, I will talk about the propagation. Propagation serves the pre-vector building in the mass because in the last case, each shows some different behavior. We can define sort of the build strength F mu as a partial mu I nu minus partial mu I mu. That comes from the electrodynamics in the relativistic version. So the such A mu is the correspond to the Bohr potential, and F mu contains the electric field strength magnetic field. And we know that the Maxwell equation can be written by the partial mu F mu equal to the J nu, where the J nu is a source term or the Bohr current. And we can insert some of the massive term, and the correspond Lagrangian can be written like that. The source terms are negative CC. So there are some kinetic terms of the vector field and the mass terms of the vector field and equation motions are given like that. If we insert the J nu I mu term, then there will be the source term will be sort of appears in the right hand side. And also we can construct such a vector field Lagrangian as the quantum field theory point of view with satisfying some Lagrangian invariance and unitarity many conditions. But in this is a particular physical, so I will focus on some simple technique, the practical point of view. So if we calculate this partial map menu with the definitions of the field strength, and there are some of the partial mu I mu equal to G gauges always occurs in this massive vector field. So the equation of motions reduces this form, partial scales plus lambda, which becomes a Klein coordination form. First, the equations can reduce in the same Klein coordination form if we multiply I gamma mu partial mu plus m. So all the Scalar, Spinor, and the vector fields satisfy the Klein coordination, and it has the plane wave solution. In this video, I only talk about the V, scalars and Spinor vector field, but actually there might be some of the additional interaction term with the Lagrangian, and it gives us some of this interaction process between the initial particle, and it gives us some of the change from the initial state to the final state. And then maybe this in the next videos will keep going on. But before that, there are focused on the was Spinor and gamma matrix in the next time.